Hey everyone, welcome to video 5E1, and this is using the law of cosines in a non-right triangle to find a missing side. So for this example, the examples in this video, you guys come right from your textbook, and that's section 7.7 on page 385. So I'm going to start with example 1, and as you can see on your handout, I just want to remind you, make sure your calculator is in degree mode, okay? Because otherwise all of these calculations, as you know, are going to get messed up. So I'm on example 1, and the first thing we want to do is we want to sketch the diagram. I also want to remind you that as you are thinking about capital letters, remember, capital letters are the same as angles, okay? Angles are always going to be labeled with those capital letters, and the lowercase letters are going to be sides. So keep that in mind. So if we're talking about angle A versus side A, okay, that's going to make sure that you're talking about angle A is the angle that is opposite side A. Okay, the angle A is opposite side A and vice versa. A is the side that is opposite angle A. Okay, so just a quick reminder about what those notations are going to mean for you guys. So in example 1, we're given the diagram, and in all of these problems here for law of cosines and finding a missing side, you're going to see me just sketch just a regular triangle. Doesn't need to be isosceles, doesn't need to be, you really don't need to know about the measurements. We're going to let the numbers speak for themselves, okay? So what we want to do here is we want to have side A, B, and C are those angles that are given. We are given that we know side little b, which is 10. We know side little c, which is 8. And we know angle A is 60 degrees. What we are asked to find in this problem is what is A. And again, this is example 1. So what we're going to do is we're going to start using this idea called the law of cosines, okay? And the law of cosines has the equation a squared equals b squared plus c squared minus 2bc cosine of A. And I know that seems really kind of arbitrary. If you want to know where exactly that formula comes from, you can look at the extension videos that are on our video lessons page toward the bottom there. Khan Academy has a proof of this that I have linked to that talks about where in the world does this formula even come from. But the most important thing that you need to realize about this formula, you guys, is that when we're talking about A and cosine of A, okay, all of the other variables are used, but whatever the variable starts with on the left, that's the angle you're taking the cosine with way over on the right, okay? So in this picture, we're going to plug in our unknowns and find our missing side little a. So our first step is going to be to plug those in. So we have a squared equals 10 squared plus 8 squared. Again, that's little b and little c. And then minus 2 times 10 times 8 cosine of the angle A that's given, which is 60 degrees. All right, so what I need to remember at this point, you guys, is that this is going to require some calculation using my calculator, and I have a separate screen capture video of the TI calculator process and steps that you guys can refer to for that. So the numbers that you see me put up here, you can find using your calculator, okay? The next step is just to simplify. So we have a squared equals 100 plus 64 minus, and then I always just multiply these three numbers out and put that as the number as a coefficient in front of the cosine. So 2 times 10 times 8 is 160. And then that's 160 times cosine of 60, okay? At this point, we can simplify by adding these two numbers here. We get a squared equals 164 minus 160 times cosine
Lizzie
of
Brown
60.
to the library, please. Lizzie Brown to the library.
You can see that I'm doing this after school. So that's going to be a squared equals 164 minus 160 times cosine of 60. And then at this point, we can really just stick it right into our calculator, and we can get an approximation for it. The calculator always gives approximation, so remember we want to use that squiggle equal sign there. And the squiggle equals, we're getting approximately 9.2, and that's going to be my answer. Okay, so that's the process as far as plugging all of those variables into the law of cosines. You guys, this is really, really, really a plug and chug type of equation. All you have to do is plug in the numbers, and then we always have to ask ourselves, remember, at the end of the problem, does this answer make sense? Okay, so let's talk about that for a second. Does this answer make sense? And I think it will, so let's look at it. If this answer makes sense, then that means that the side that I just found is my third side. And if you recall what we talked about as we talked about our unit on triangles a little while ago, is that that third side always has to be stuck between two numbers. And those two numbers are found by taking either the difference to find the lower bound or the sum of the other two sides. So remember, we have the third side is always equal to the first two sides subtracted, and then that can be, you want to make sure that's a positive value, that you subtracted the weight to get a positive number there, and that this is the other two sides added together, okay? So what we're looking at, in our case here, we're looking at does A, which is the third side, we actually would make sure that this was C minus B and C plus B. So it's got to be between the difference of the other two sides and the sum of the other two sides. And so let's see if that works out. The A that we found was 9.2. So we're going to ask ourselves, is this true here? Is that going to be 9.2, is that greater than the other two sides subtracted, which will be 10 minus 8? And is it going to be less than the other two sides added together? And I think you can see that that is true. So yes, it does make sense. Okay, so we can be assured that this answer down here is right, that it does make sense. So that's what we're looking at as far as the law of cosines goes for our first example. And to find your second example, we're going to go on to example 1B, and that is not in your book, but I'm going to put that up there right now. So take some time and just look back over this, and then the next video we'll go on to the next example.